Myself, K. Ramesh, of roll number 924 PGC001. I completed my project along with CH Jagdishwar Reddy of 13 under the guidance of Dr. Srinivas Deshikan and Dr. Rangababu sir. And my project name is Remote Monitoring and Automatic Protection System for Solar Power Plant. And it is the evaluation sheet, examiner signatures and supervisor signatures. Coming to this, here the objective is to protect the solar plant by using an IoT system. So to optimize the system, I have taken a simple DC supply because solar plant gives DC output. So instead of taking solar panels, etc., etc., I have taken a simple laptop charger which is giving an output of 12 volts. And this 12 volts directly I have taken, and this setup can be treated as a solar plant. Now I require low voltage supply for IoT devices such as ESP32, which is going to act as a Wi-Fi module, and Arduino 3.3 volts, to INA 219 sensor, which is to measure voltage and current, and a relay. Here it takes 5 volts input, and the load is DC motor. The thing is, solar power is getting generating, and using that solar power, this motor is working, and my protection system, that too automatic protection system, will act in such a fashion that when this particular load experiences a voltage 12 volts or more, it will be over voltage, it treats it as a over voltage, then the relay action will comes into force, and it will disconnect the circuit. Similar way, if the current is more than 450 milliamperes, then also the relay comes into action, and it will disconnect the system, so that our solar plant will be safe and our load will be safe. Once the disconnection has been made, after 20 seconds, again the relay checks whether what is the voltage and what is the current coming into the system. If it okays within the sustainable limits, then it starts working again. In this way, it will be automatically protected. And how this is remotely connected by means of using ThinkSpeak Cloud platform. So coming to this, this is used as a Wi-Fi module, and this is the sensor, current and voltage, and by using SCL and SDA connections, by using pull-up resistors, these are pull-up resistors of 4.7 K, and this is one more pull-up resistor of 0.1 ohms. Through this, the motor currents and voltages are sensed by these sensors, and these sensing values have been sent to the Arduino. And by using the Wi-Fi communication module, we made use of HTTP protocol for cloud transfer. Once the cloud transfer has been taken, the processing has been done, and depending upon the thresholds we set, that is 12 volts for over voltage and 450 milliamperes for over current, the actions will be taken place, and accordingly the relay operation will be taken place. So over this project we have conducted number of case studies, around 6 case studies. Each a case study will be varying the voltage in 5 steps of 1 volt. So for the variation of the voltage, here the voltage regulator has been taken. The voltage regulator is supposed to take this 12 volt supply, and with the fine tuning of this variable resistance part, we can vary this resistance up to 35 volts, so that the motor experiences different in voltages, so as the voltage experienced by the motor, and hence the currents will be varying in such fashions. Whatever the over voltage, whatever the over current experiences, then the relay action comes into force, and all these things have been shown in the form of results here. So here number of case studies have been conducted, because with the inclusion of these resistances, the current flowing through the motor can be varied, and under these circumstances, the relay status was made to trip. This is theoretically done, and of course, the same thing was done in the ThinkSpeak using the ThinkSpeak platform, and the plots are customized like this. This is the threshold value of 12 volts, and wherever the relay trips occurs, the peaks shows like this. So likewise, different case studies have been studied, and totally 50 number of samples have been collected over the entire process. Out of these 50 number of samples, it was observed that there were only only two cases out of 50. It was shown that a relatively very error, small error. So that's why the accuracy of this was said to be uh, 96% it was calculated. So in this way the setup was able to sustain over voltages as well as over currents from the system, and this can be implemented for various applications of protection of solar power systems. And here the thing is the best optimization and the best